Okay, guys, today I want to talk about Popper's problem of induction, and this is intimately related to the video I did previously on Hume's problem of induction. So go check that out if you want a background on what kind of came before these questions. But today I'll be addressing Popper's problem and some of the positivist problems as well. So to really appreciate what Popper is doing here is we need to think about the positivists. So Popper did most of his work in the 20th century, and before him, mostly the positivists, although it's contested a little bit, the positivists mostly reigned in the philosophy of science. So the first question that any philosopher of science needs to address is the demarcation problem, which is essentially to identify what discipline or disciplines are science. So is metaphysics science, is math science? And the positivists are going to say that the math, logic, metaphysics, these are all science, and what is non-scientific are things that are meaningless. So only meaningless disciplines or statements are non-scientific. So the positivists also believed for theory discovery. So you go out, how to actually discover theory, the theories that are true. Theories that are the most probable are the theories that we should start to test and start to identify as likely, as prospective theories that could be true. Thirdly, they state that science starts with observations and then proceeds into theories. So you start with things that you can see in the world, and then you move to more universal general statements about the world that are theoretical. And lastly, the positivists demand a pretty strict correlation, tight hermetic seal between theory and observation. And what this means is that you can have theoretical geometry that says that an isosceles triangle has these certain degrees of internal angles or whatever, and the instantiation in the world of what is going to obtain that theoretical category of being an isosceles triangle is going to be the same in both categories. There's not going to be cases where in theoretical geometry you're going to get a triangle that isn't isosceles and breaks some rule, and they're one-to-one. So theoretical cases that are isosceles triangles are going to in fact be specific real cases where triangles are actually isosceles. So there's no separation between what is theoretically true and what is specifically true. So Popper comes along and he has a lot of quibbles, the first of which being about the demarcation problem that we just talked about. So he says that, well, things that are meaningless are not science, but metaphysics, logic, and math are also not science because you can't test them, you can't falsify them. So if you know anything about Hume, I talked about him in my last video, you'll know that there's things that are demonstrably true, or a priori, however you want to talk about it, things that are true that you don't have to go out in the world and observe to know. So science is the practice of confirming things through observation and making them survive these observations. Math is true for other reasons. Math is demonstrably true, which means that 1 + 1 is true, not by the matter of fact of the world, but by the fact that the rules that we've set up beforehand make it true by that matter of fact. It's not true because of something we see in the world. It's true because 1 + 1 is 2. So it's not just meaningless statements from Popper. It's logic, math, metaphysics. These are not testable and therefore not science. So a problem that persisted for both the positivist and Popper was the problem of universal statements being invalidated by modus tollens. And we'll get an example of this very quickly on the next slide. But this problem made Popper conclude that induction isn't actually how science proceeds, and that's how the positivists construe science proceeding. And this presents a problem for the positivists' idea that observation needs to come first, and then we make theories. So the problem with this is that don't worry too much about the formal predicate logic here. It's not super important. Just let A stand for the universal statement, all swans are white. And then let B stand for you see a white swan. So we have we go out in the world, we observe 1,000 white swans. Okay, that's easy enough. Come back and we say, well, what have we learned about swans? We can say that all swans are white, right? So the problem here is that if all swans are white, then we should see white swans, right? One instance of this, seeing a black swan, say, you don't see a white swan, you see a black swan. You can invalidate that universal principle by just seeing one black swan. So this is an inductive statement, and it's a statement that no matter how much observation we make, it can be invalidated by one simple instance of the contrary. So this is a problem for the positivists, and this is a problem that Popper says is why science doesn't proceed but through induction, because, well, why would we do this if we could just make one observation and it's going to make all of our theories come crashing down on our heads? So that's a problem that Popper tries to address. We'll see more examples of that later. But another thing that Popper quibbles with is that the positivists have a position of probability and theory discovery. So this can be, you intuitively have this idea that this is true, that we should think that the most probable theories, the theories that have the most probability of being true, are probably the theories that are correct, right? That sounds intuitively correct, but this doesn't really stand up in Popper's view, because really complicated theories are needed to explain the phenomena in the world. So if that's true, and that we should take the most probable theory and accept it as probably the more true one, we're going to have cases where simpler theories are going to always beat out more complex theories in terms of probability. So that's going to shy us away from the complex theories. We're thinking, oh, that's too many basic statements, that's too complex, it's too unlikely. We can't really think that way in Popper's view. So this can be demonstrated by something that Tversky and Kahneman kind of pioneered. This is called the conjunction fallacy. So Linda's a 31-year-old single, outspoken, very bright. She majored in philosophy. As a student, she was deeply concerned with the issues of discrimination and social justice, and she participated in anti-nuclear demonstrations. Which one of the following basic statements is more probable? So 1 and 2 both have this first basic statement, right? Linda is a bank teller, Linda is a bank teller, but 2 has an additional 1. So there's 2 basic statements in the second one. So using what we know, our information about Linda, most people think that 2 is more probable. And if you're an astute listener, you'll probably realize that that sounds fishy, because there's 2 basic statements here. And if you know anything about probability theory, you'll know that 2 statements combined together can never be more probable than the highest probability of the individual statements. So this is a problem, right? So if you think about any theory, think about gravity, think about string theory, whatever, there's a lot of basic statements in those, and they're very complex. So how could they possibly be true, right? How could they possibly be true? We have, good reason to believe that the theory of gravity is true, but it's very complex. There's a lot of weird things going on with it even now that we don't super understand, but it's probably true. It's probably pretty close to the truth. But More simple theories are more probable. Other explanations that aren't gravity, that have less basic statements in them, should naturally guide us towards thinking that those are true rather than the theory of gravity. So this is a kind of summary of what we talked about, but I'll start with what I was just addressing, the probability of the problem of probability being used for theory discovery. So this is the Thelinda fallacy, and you can take a look at this if you want, but this is a mimicked version of a more theoretical construction of it, which is a bit more difficult to understand. So we'll just talk about this, as this is going to be more constructive. So we have two basic statements here, right? So probability, 90% probability here, 50% probability here. When we combine them together, so A, probability of A union B, that's going to be always less than the least probable theory. So you can't have, so if these are both 0.9, you still wouldn't get more probable than just 0.9, right? So since this is 0.5, we have to go with the lower probability of 0.45. So as you can see, this is a 50% probability. This is that's a pretty good, it's a pretty likely basic statement. You can imagine basic statements being, equally or less probable. If we attach them into this calculus, it's going to drastically go down very quickly to the point that, 5 basic statements are going to make our probability of this theory being true. It'll basically go down to 0. So Popper doesn't like this. So it's never going to, your probability of A and B being true is never going to be higher than A or B. So this is why, and you can see here, so the overlapping areas A and B, it's always going to be smaller, right? Even if they're totally overlapping, it's not going to be bigger than, the biggest, the smallest one. So the probability of AB being true can never be greater than the smallest of either A or B. So Popper says that we want highly unlikely theories, and more often than not, highly unlikely theories create a lot of empirical content. And why that's important is that makes a lot more things that you can say that shouldn't occur for a theory to make it more falsifiable. And what do I mean by that? Well, let's go down here. So this chart is going to be showing, so on the x-axis, we have hypothesis testability. On the y-axis, we have range of permitted events. So the way to think about this is that when you have a lot of permitted events in a theory, that means there's not a lot of testability in your theory. There's not a lot of empirical content. So imagine a theory that says anything goes. Anything that you can observe is going to be consistent with my theory that all swans are white. Anything. It doesn't have to be pertaining to swans. It can be a lamp. Any observation is going to be consistent with my theory. Well, you can do that, but the problem is you're going to have a very low testability. You're not going to be able to make any observation to disconfirm that theory. So in Popper's view, this is the way we should be looking at science. We should be constructing theories that are highly unlikely, and that we can actually know what observation is going to be in the world when we record it that will disconfirm or at least make problems for our theory. So really, we want to make as few permitted events as possible. So there's only a couple things in the world that can happen that will confirm my theory. That's going to make your testability very high. So that's good. We want something that is testable, something that we can test quickly, easily. And if it's true, it's true. If it survives, that's going to be evidence of a good theory, according to Popper. So to kind of bring it all together and to take an overview here, we can see on the top part here, this is the positivist tradition, how they run, and then how Popper runs, and kind of as a synthesis, we can bring it all together here. So for Popper, he's going to reject that we start with observation because of the problem of induction, the swan problem that we talked about. Popper's going to say that science starts with a problem. And you might be wondering, how do we get these problems? And you can pick at this and say and see how it just keeps going back to being about observations, but let's not worry about that. So second stage is going to be a hypothesis formed by basic statements. And again, the positivists are going to be inductively forming hypothesis. And this is, again, a problem with the Swan view. And again, a problem for these basic statements. You're going to be making these hypotheses out of basic statements, right? So if you're looking for these really probable theories, according to the positivists, you're going to be favoring really simple theories that don't really tell you much. But for Popper, you're going to make these basic statements up, and you're going to, turn it into a theory, and you're going to test it, and you're going to try to falsify it. And the positivists, they had the same kind of conception of this, but ultimately, Popper is going to reject this leap that they make, where they go from the hypothesis surviving to being more probable. The probability of it being true with each falsification runs into the same problem of theory discovery. So it doesn't matter how many observations you make, your hypothesis is only going to be as probable as the basic statements, which, as we saw, there's a problem there. And for Popper, the ability to survive severe tests is going to be the end road, which is going to be hard to distinguish right now if you haven't read both Popper and the positivists. These might seem very similar, but really they're fairly distinct, but there are issues with both. But for Popper, we just need to come up with these theories and just test them rigorously, whereas probability plays an intimate role with the positivists in theory discovery and ultimate justification. So I hope this is all kind of brought clearly into view, and I hope you enjoyed. Hopefully I'll be doing another one. Haven't quite got the topic, but thanks for tuning in, and have a good day.